Hey y'all, and welcome to the next lecture in practical packet analysis. And we're going to enter the protocol section of the course now, and we're going to start from the bottom of the OSI model and start with data link layer protocols. Now, since this is the first lecture where we're going to really dig into some specifics about how protocols work, I want to briefly describe the approach I'm going to take that's going to be fairly consistent throughout all the different protocols we're going to discuss, all the way from the data link layer up to the application layer. Now, first of all, we'll start discussing the features and structure of the protocol. So each protocol has a specific purpose, which I'll talk about, and I'll talk about the different features that allow that to happen and the different features that are related to that, either primary or secondary features that support the overall function of the specific protocol. From there, I'll also talk about the structure of the protocol, and specifically, we'll look at the packet map or the packet diagram and show the different fields that exist in the protocol and how that's structured, so you can kind of get a sense of the different data points that allow the protocol to deliver all the features that it provides. From there, we're going to talk about protocols in terms of stimulus and response. So generally, with any type of computing, you have some type of stimulus and there's some type of response, and there's a concert of stimulus and response that goes back and forth between one host and another host, or one host and many hosts, and that's what allows communication to occur. So we are talking about active communication here. So every protocol is going to have a stimulus and response component that we're going to discuss. Of course, stimulus and response comes in a couple different flavors. Specifically, there's normal stimulus and response, which is the stimulus and response is expected based upon the way the protocol is spec'd out and designed, and so we'll cover what normal looks like. And then we'll talk about abnormal stimulus and response, and we'll talk specifically about certain features of different protocols that can be exploited for security purposes, or things that maybe just malfunction a little bit. So we'll cover a little bit of that here. So for instance, we'll talk about ARP cache poisoning when we talk about the ARP protocol, and how that can be used for malicious and useful purposes, but it's still an exploitation of kind of the way that protocol is supposed to work. So we'll talk about that abnormal stimulus and response, but we'll also go into some things a little more specifically later on. So for instance, when we talk about TCP, we'll talk about TCP sequence and acknowledgement numbers, which are used to track state and deal with latency, but we'll not really dive super hard into latency until we get to that specific section later on. So we'll get into some of these things now, but we'll focus on stimulus and response and that sort of framework for learning about these different protocols. Now, our objectives for this module, when we're talking about data link layers, are pretty simple. There's really only two protocols we're going to look at here. The first is the Ethernet protocol, and then the ARP protocol, which is used to translate IP addresses to MAC addresses. So we'll talk about those two protocols here, again, using that framework we just discussed, where we talk about the features and structure, and then go into normal and abnormal stimulus and response. The data link layer, as I've mentioned previously when we kind of did our fundamentals of network security discussion, it's the bottommost layer, second to the bottom layer of the OSI model, right above the physical layer, and it's really the lowest level layer that we'll deal with. And it's got a few different responsibilities. Primary amongst those is the need to provide addresses that are unique to network interfaces. And I say network interfaces specifically because I'm not talking about computers, because a computer can have multiple network interfaces. You can certainly have two network interface cards. Probably the computer you're watching this from has a physical NIC and a wireless NIC. So those are two different interfaces, and each one has its own hardware address. In this case, probably a MAC address. So data link layer is primarily responsible for that addressing. So we'll talk about that in the context specifically of Ethernet for us. But it's important to note that there are a few different options at the data link layer. Now, there's the term 802.x, which you'll hear and read about, and that's kind of just a term used to generally refer to any data link layer protocol, and that's going to include the ones I'm going to mention here. Of course, Ethernet is what we're going to talk about. That's 802.3, but you're also probably familiar with 802.11, which is the wireless specification, which is a data link layer protocol in itself. And we also have 802.15.1, which is the Bluetooth specs. So we have a couple different things here, and you may have not realized that wireless or Bluetooth were necessarily data link layer protocols, but in this sense, when we're referring to 802.11 and 802.15.1, they are. Now, again, that said, we're going to focus exclusively here on 802.3 on Ethernet. because that's generally what you're going to be dealing with most of the time, and that really explains a lot of the concepts we need to understand in regards MAC addresses and things like that. So let's go ahead and get into that. We'll talk about Ethernet, and then we'll pivot over to ARP, which isn't necessarily a data link layer in the same sense that the Ethernet is. But it is a protocol that exists mostly at the data link layer and is used to help the data link layer translate perfectly well up to the network layer, which is what we're going to cover next. So let's get moving.